Many 10-year-olds find traditional science textbooks entirely abstract. Formulas on a page rarely spark engagement when they lack a clear connection to a student's daily life. To bridge this gap, Indonesia implemented a nationwide overhaul of its education system known as the Independent Curriculum, or Curriculum Merdeka. The engine driving this national policy is the Pancasila Student Profile. It tasks schools with building character and critical thinking by having students solve tangible problems within their own local environment. By pulling education out of the textbook and into the community, the curriculum requires students to apply what they learn to the world around them. We can see this in action in the special region of Yogyakarta, an area famous for its deep cultural roots. Fourth-grade students at SD Negeri Jambon 2 are tasked with operating a functioning startup as part of their Ethno-STEM challenge. Their objective is to manufacture and sell bakpia, a traditional sweet roll that is a staple of local Indonesian culture. To successfully launch this product at their school's Market Day, these students must master 4 distinct pillars of business and science. This specialized E-module guides students through the first phase of their startup, research and development. The project requires tracking the physical science of baking. As they knead dough, they measure the conversion of potential muscular energy into kinetic energy. The analysis continues inside the oven. Students track how electrical energy converts into thermal energy, which then drives the chemical reactions that bake the pastry. Alongside the physics, they use smartphones and computers to research manufacturing techniques, comparing traditional handcrafting tools with modern industrial equipment. Tracking these real-time physical energy shifts bridges the gap between theoretical textbook physics and the practical reality of commercial food production. With the science understood, the students move into the engineering phase. Success in the market depends on creating a product that stands out from the competition. The students brainstorm ways to innovate past the standard recipe, designing completely new flavor profiles and experimenting with unique physical shapes. This requires moving through the engineering design process, which relies heavily on failure. Early prototypes of their new flavors often clash, and untested shapes can crack and burn in the oven. The students systematically log these failures, analyzing what went wrong with the heat distribution or the ingredient ratios to revise their prototypes into a viable product. The iterative process builds the resilience required to move past inevitable failures.
Even a perfected pastry will fail if the underlying business model is broken, bringing the students to the financial math of a startup. This chart aggregates the costs of raw materials, flour, sugar, custom fillings, calculating the total initial capital required. The students then divide this expenditure to determine the exact cost per unit, checking it against traditional manufacturing methods. With baseline costs established, they analyze the local market to set a competitive selling price, one that attracts buyers while guaranteeing a profit margin for their team. Financial modeling provides a practical necessity for arithmetic, making it an essential tool for business survival. All of this preparation culminates in Market Day, where the school grounds transform into a bustling public bazaar. The fourth graders set up their stalls to exhibit, pitch, and sell their newly engineered bakpia directly to their peers, teachers, and parents. As inventory moves, they experience an immediate feedback loop. They calculate their sales proceeds in real time and realize actual cash profit. Through this process, they execute a complete entrepreneurial product lifecycle, moving a product from an abstract concept to a market launch. Data confirms the success of this implementation. This page from the research report details an 88% positive response rate from students, showing high engagement with the project-based learning module. By launching their products, these students explicitly achieved their primary objective, the curriculum sub-theme of becoming a successful entrepreneur. The ethno-STEM approach preserves regional cultural heritage, while simultaneously embedding hard scientific and economic skills into a younger generation. Bridging the gap between cultural roots and scientific application allows students to enter the real economy as capable creators.